A white dwarf star pulls matter of a companion red giant star until a powerful nuclear fusion explosion occurs on the dwarf's surface. In this process, the star is not destroyed and additional explosions can occur, and this phenomenon called a nova.
Hi, my name is Nurul Syuhada binti Aris Pazilah with matric number 170797338. I am from Department of Physics, University of Malaya. I would like to present my final year project on spectroscopic study of novae. I am supervised by Dr. Nazatul Shima. Nova come from Latin words which mean new. Novae are stellar eruptions that occur in what we call a cataclysmic variable system. This is a binary system consisting of a white dwarf accreting material from the Roche-Loeb-Filling companion by an accretion disk. So, the material built up on the surface of the white dwarf, increasing the pressure and density. And at a certain critical point, thermonuclear runaway triggered on the surface of the white dwarf, ejecting at least parts of the accreted envelope with velocities ranging between 500 to 5,000 km per second. This system is caused by the outburst of novae. The outburst ejects nuclear process elements into the interstellar medium and thus lead to the enrichment of specific isotopes. A standardized increase in mass is possible depending on the net gain or loss of material by the white dwarf from the accretion and episodic ejection of gas in outbursts, leading to its collapse if its mass grows to exceed the Chandrasekhar limit of 1.4 solar mass per year. When the process is over, the accretion resumes on the surface of the white dwarf, building up the following eruption. So, basically, novae, accrete, erupt, and repeat. Recently, the exciting physics they represent have resulted in more intense analysis than before. Spectroscopy continues to be the most effective tool for studying novae. Spectroscopy contributes much more specific details, information, and is more challenging to collect consistently. They are the emission lines terminated and typically show strong emission lines and broad emission lines of Balmer, Ferrum-2, oxygen, helium, and nitrogen. Novae has been studied for a long time where data were taken by using the photographic plates. And during this 21st century, data taking has been more advanced than before, which we were introduced to the more advanced technique using the charge-coupled device and high-grade digital camera with high-resolution spectrograph to obtain high-resolution spectra. So, the objective of this study is to investigate the elements produced by novae through the spectroscopy analysis. An emission line spectrum is produced by novae gas ejected in both the shell and the wind following the outburst. The spectrum analysis is a useful tool for understanding the many processes associated with the outburst, including the formation of dust, the nuclear reaction, and the gas ejection mechanisms. So in this study, I choose a nova named Nova Centauri 2013 and also known as V1369 Cents. It was a bright nova in the constellation of Centaurus that occurred in 2013. It was discovered by Australian observer John Search on December 2nd. On December 14, 2013, it peaked at magnitude 3.3, making it the brightest nova so far of this millennium. In July 2015, it was announced that lithium has been detected in the material ejected from Nova Centauri 2013. This is the first time lithium has been detected in a nova system. So now, novae are the main contributor to the lithium abundances in the galaxy. So thanks to the novae, we can use our devices today. For methodology, I have taken a sample of a nova's data from Aris database and choose V1369 Cent as this novae has a variety of spectra to analyze, as you can see here. After that, I choose a nova on 3rd of January 2014 with the resolution of 11,000. Then I extract and analyze it into the software called Visual Spec. Absorption lines originating from many elements such as hydrogen, helium, and ferrum are identified in the observed spectra. Among them, there are a set of strong absorption lines in the ultraviolet range of spectrum. Comparing these lines with other lines originating from hydrogen, calcium, and other elements, it turns out that they are originating from an isotope of beryllium, 7 beryllium, which is the fourth lightest element in the universe. In a classical nova, the isotope of helium, 3 helium, and plentiful 4 helium transferring from a companion are fused together to form radioactive 7 beryllium in a very high temperature environment on the surface of a white dwarf. This radioactive isotope decays to form an isotope of lithium, 7 lithium, within a short time, half-life of 55.22 days. Because 7 lithium is a very fragile in high temperature environment, it is necessary to transport 7 beryllium to a cooler region in order to enrich lithium in the interstellar medium. Novae completely fills this requirement. Therefore, they are assumed to be strong candidates as suppliers of lithium in the universe. That's all from me.